Here we go. Let's finish this up. All right, so we have this table of values that gives us 3 functions. And on A, we're going to find 2 of f of g of 2 plus 3 times g of h of 0. So we can do it finding everything all separately like we had, but we can also just leave it as kind of an equation and say this is going to be 2 times f of, well, what is g of 2? Negative 3 plus 3 times g of, what is h of 0? So can I multiply this 2 times this negative 3 here? No, that doesn't make any sense. So then this is going to be 2 times, what is f of negative 3? Negative 4 plus 3 times, what's g of 3? 2. So that gives me negative 8 plus 6, which is negative 2. A little more organized way of doing it, but whatever you need to do to be able to get all this stuff done is fine. All right, so then we have h of g of negative 2 times f of g of 2. So this gives me h of, all right, what's g of negative 2? Negative 1 times f of g of 2. What is g of 2? Negative 3. So then I get h of negative 1, which is 1.5, times f of negative 3, which is negative 4. And then what is 1.5 times negative 4? Negative 6. Everybody good? Right? Okay. All right, so then we want, says if k of x equals the absolute value of 3x minus 4, for what values of x is k of x equal to f of g of 0? Is k of x something that we can calculate from this right here? No, right? Like we don't know, that doesn't make any sense. But it says for what values of x is k of x equal to f of g of 0? So that means that k of x is equal to f of, what is g of 0? 1, okay. And then k of x is equal to, what's f of 1? 4, okay. So it's saying for what values of x is k of x equal to 4, basically, right? So do I take this 4 and substitute it into the absolute value? No, because this doesn't represent x, does it? It represents k of x. So if I can substitute it in right there, that means that 4 is equal to the absolute value of 3x minus 4. And I want to know what values of x make that true. When you solve an absolute value, how many answers are you most likely going to have? 2. So I'm going to take this 3x minus 4, and I can set it equal to 4. But then I also take 3x minus 4 and set it equal to what? Negative 4. Okay? And then I solve them both. So 3x equals 8. X equals 8/3. Is 8/3 an acceptable number to change into a decimal? No, it is not. Okay? Because that is going to give me a repeating decimal. That's a big fat no. Even if it was acceptable, I would still want to leave it like this. And then over here, what does x equal? 0. 3x equals 0, x equals 0. Everybody good with that? Got to know how to solve absolute values. Got to know how to solve everything you've ever learned. All right, we good? All right, so let's look at example 8. It says to describe the transformations of the compositions of functions given. We're going to describe the transformations of the quadratic parent function. Okay, just y equals x squared. or basically the transformations of f of x. I'll tell you why we're looking at it that way in just a minute. So we're going to have f of g of x. So f of g of x means I want f of x minus 1, which is, when I substitute it in there, x minus 1 squared. So what is that transformation? What happens from, so if we just have y equals x squared, we know it looks like this, right? That's what our parent function looks like. What does this do to it? Move it to the right one. So to say move it to the right one, we say that is a horizontal what? Translation? Right one. So we're also going to pretend like these graphs don't have any little hash marks on them, okay? Because we're not going to plot every single little point. We know what the parent function looks like. We're going to move it to the right one, and so now it looks like that. And I say we're pretending just because I don't want to have to worry about what the actual other points are. We're worried about the translation, which doesn't even look like one after I drew it in there, now that I look at it. Let me fix that. Well, that's a little better, but not a whole lot better. But I can't aim well with this pen. But you get the idea, right? You're moving it to the right one, and it's all yes. So you could probably I could do a much better job with a pencil on a piece of paper. Okay, so now, excuse me. Now we have f of h of x. F of and h of x is 2x. That is equal to 2x squared once I substitute it in there. What kind of transformation is that? First of all, is it horizontal or vertical? Horizontal, so I know it's a horizontal something. Horizontal, what? Dilation, good. By what? 1/2, very good. Okay. Which means we take our parent function, but we squish it in, which makes it look skinnier, right? So it looks something like that to be a little bit skinnier. Now, could I, both of these, after I substituted in, like I could have simplified it, right? I could have squared this out, which is not x squared plus 1, by the way, or x squared minus 1. But that wouldn't have helped me with transformations here. But if I actually square this, what I end up with is y equals 4x squared like this, right? What type of transformation is this? Vertical what? Dilation by 4. So that means I would take my x squared and I would stretch it up and still make it skinny, right? But I would end up with the exact same thing. Whether I have a horizontal dilation by 1/2 or a vertical dilation by 4 on this function, they're going to look exactly the same. Okay? You okay with that? All right, good deal. All right, so then we have, and I also want you to notice this, that this is like, remember how we see the generic ones sometimes, like this, right? This is the exact same thing. Whether I put it in the x squared or not, it's still just a horizontal translation, right? 1 and a horizontal dilation by 1/2. But when they're generic like this, I just wouldn't know if it's a quadratic or whatever else it is, right? Okay, so then we have g of f of x, so that's g of x squared, and that's equal to, once I substitute it in there, I get x squared minus 1. Okay, so I said at the beginning that we're going to look at these as transformations of the quadratic parent function, because this is really, when we do g of f of x, it's really a transformation of the g of x function. So we're taking a linear and making it into a quadratic by, squaring that x there. But I don't want to get all deep into that stuff. So we're just going to look at it from this perspective right here. And so what is this? What kind of translation? Vertical. Okay. So vertical translation and I'm going to write this a little bit differently. I'm going to put by -1. And I'm putting it like that because that's how it's written sometimes in your answer choices, right? Instead of saying left or right, it gives either a positive or a negative. You could do it either way, okay? Use the same thing. But basically, this one goes down 1, and it shouldn't be as skinny, so it would look something like that. But not real flat like that, but I'm not redoing it. Because you know what a quadratic looks like. I'm not worried about that. All right, any questions at all? We good? Perfect.